Now we move on into feature encoding. Now remember that algorithms prefer to work with text or numeric values. The algorithms that are going to do the training, the actual training, to extract the pattern from the data set, do they prefer text or numeric values? Let's find the last person. Do they prefer text or numeric values? The algorithms. Text or numeric? Numeric, right? So algorithms like to work with numbers, right, than text. How about if we have like ocean proximity? We already knew we have one column inside of data set, which is text, like near ocean, near bay, less than 1 hour away from the ocean, and so on and so forth. Then we need to find a way to map between this text and some numeric value. And this process, we call it feature encoding, where you provide code number to every unique text value you have inside your data set. Okay, clear what is feature encoding? So it's about handling text and categorical attributes by assigning numeric value into them. How we do now, we're gonna discuss about. Okay, consider this example. Firstly, categorical data is non-numeric, everyone knows, comprising labels or qualitative. We call qualitative value. Qualitative. Quantitative refers, we have this term used in the slide earlier. Quantitative means numeric value. Qualitative means non-numeric value. Can be text, can be labels, whatever you have. So a machine learning model cannot process categorical variables directly. So encoding techniques are employed to convert categorical data into numeric form. Okay, so let's take an example, and then let's think together about it. Let's say you have this data set. Actually, this data set is similar from the slide, where it shows you about the tool type, pen, pencil, eraser, and tool rating, and so on. Let's say these values collected by each customer. So the first customer ID is 101. He maybe purchased the pen, and the rating for the tool he purchased, he marked it as excellent, and so on and so forth. So now we have two qualitative columns. Two qualitative columns are, what are the qualitative columns we have here? Exactly, so we have tool type and tool rating. Now, in order to map or provide mapping value, numeric value to these, what you need to know first. First, then, you need to know whether these variables are nominal or ordinal, because each type has different treatment, different ways of mapping. So what is the tool type, data type? Let's pick a person. Anyone sleepy? You look sleepy. Yes. So what is the type or tool type? What is the data type? Referring to whether it's nominal, ordinal, or maybe you like to say it's a numeric. Is it nominal or ordinal? Sorry? Ordinal. Why? What is ordinal? Let's do a refreshment. What is ordinal? Ordinal. What is ordinal attribute? Sorry? Can you speak up? Ranking. Firstly, it's qualitative, must be qualitative. Second, it has nature of ranking. Okay, so keep this in mind. Must be qualitative, like this one, and must have nature of ranking. Do you have nature of ranking for the different types of tools? Pen, pencil, eraser? Do you have nature of ranking? Can you say pencil? Can you use greater than and less than by pencil and these stuff? No, right? Unless if the question say, but here doesn't say anything. So we can assume there's no nature of ranking. So in this case, cannot be ordinal, right? Because it doesn't have nature of ranking. So it must be nominal, because nominal is qualitative, plus it doesn't preserve nature of ranking, like this example. So this attribute, you can mark first, it is nominal. How about the second one? Tool rating. Is it nominal or ordinal? Let's find someone. The last one at the corner, the white t-shirt. Is it nominal or ordinal? Sorry? Nominal. Why? Anybody can help? Is it nominal or ordinal? Nominal or ordinal? Ordinal. Good. Why? Firstly, it is qualitative or not? Is it qualitative? Qualitative. Then has nature of ranking. So which ranking is the highest? I ask you. Excellent. What is the lowest? Bad. You see? So very easy. You can rank them, knowing which is the worst, which is the best. So that means it has nature of ranking. You can't tell, right? But if I tell you excellent 1, excellent 2, excellent 3, or you may be difficult to understand which one is good or bad. Okay? Anyway, the point is if you see nature of ranking, then it is ordinal. So the second one is ordinal. So the first one, the tool type, is nominal. The second one is ordinal. Now, think about for a moment how you could replace these these categorical values by numbers. What do you propose? Let's go to the tool type. Or let's start with tool rating, easier. Tool rating. Just use the common sense. You don't need really to be data miner. Okay, so you preserve the nature of ranking. For example, you may replace excellent by the value of 3, good by the value of 2, 1, the value represent the value bad. We preserve the nature of ranking, right? In this case, we still have, because 2 is higher than 1, 3 is higher than 2, and 1, and so on. Right? So we can preserve in this way the nature of ranking, right? Or if you like to use encoding 0, 1, 2, also fine. So you put 2 for excellent, 1 for good, 0 for bad, also fine. They still have nature of ranking. How about tool type? Tool type, can we use the same way? We say, for example, pen is 3, pencil is 2, eraser is 1. If we do so, what would happen? If we apply the same treatment of ordinal feature or attribute on the nominal. Guys, you can try, write down, think. I want you just to be active. So what do you think? If we use the same way of treating ordinal features by nominal, what would happen? If I assign, for example, pen by the value of 3, pencil by the value of 2, eraser by the value of 1. Is it acceptable? Acceptable. How about you? Acceptable. Anyone have other opinion? Guys, no, nothing to worry about. Raise your hand, speak, I'm fine. Even you don't need to raise your hand, just speak, also fine. Now, if you assign 1, 2, 3 in this way, can't we argue in this case, if you put pen the value of 3, pencil value of 2, that means pen is higher as ranking because 3 is larger than 2 or greater than 2. And in this case, pencil is also greater than eraser. So in that case, we cannot apply this method because after all, you are referring, now you are making this attribute as ordinal. Okay, unintentionally, you have made this feature as ordinal by assigning 1, 2, 3. Now 3 is larger than 2, larger than 1. So the algorithm may think that pen has more or higher ranking than pencil. Pencil has higher ranking of eraser. Correct? You got the point why this cannot be? So we need to avoid this nature of ranking because the attribute by itself doesn't have. If it has, then no issue. You can treat it as ordinal. But it doesn't have. Unless if the task or maybe the expert on this task tell you no, it has, then that's fine. But otherwise, we cannot assume that there's nature of ranking. Now, the easy way, what you need to do, very simple. Firstly, as we said, now we already understood the data. So the data type, in this case, we can say it's nominal. Tool rating is ordinal, and these are the values. Now we come to feature encoding. This is just to show you what is the meaning for each one. So nominal encoding, convert nominal category into numeric format, or label encoding. I think here there's using one-hot encoder. Using one-hot encoding or label encoding. Tool rating, convert the ordinal category, in this case, into numeric feature by using order methods, like what we explained now. So let's look into the nominal. The nominal can be applied by what's called one-hot encoding. So what we do, first we go and create binary column for each tool type. We have pen, pencil, eraser. Then you add a new column for each value type you have under the nominal feature. So you have one column for pen, one column for pencil, one column for eraser. This is the first step. Then you label the encoding sorry, let's focus on this. Then what do? You go to 101. What is the value for 101? Earlier, what we have the value for 101? 101 is pen, correct? Is pen. So you go to the column pen and mark the value by 1. The rest, 0, 0. Then we go to 102. What is the value for 102? 102 is pencil. Then you go to 102 and put pencil 1, the other column 0. So why we do it like this way? To avoid creating nature of ranking. So all attributes have either 0 or 1, right? We don't have ranking in this case. We have separate column, pen. So 1 means the first customer has rated pen. The second one, 102, has rated the pencil. That's it. We are not creating ranking, each column on its own. So 0 means not exist. Maybe the customer didn't rate. 1 means the customer has rated this item. So only you can use 0 and 1. And not only 0 and 1, each attribute value is going to be in separate column. Now, can you say pen is more important than pencil by this representation? Never. Even they're not in the same column, so you cannot compare them. Unlike in ordinal, they sit in the same column. But now each attribute has separate. Like when you say, for example, you have a question and you answer yes and no. So we put here column for yes. Then if yes, you mark 1. If no, you go to the column no, you mark 1. So in this case, we don't create any nature of ranking among the attributes by this way. This way will help you. Now, do you need to do this manually when you are writing your code? Definitely not. You can simply, we have a class called one-hot encoder. Why they call it one-hot? One-hot encoder means you have one value like hot and cold. So for the hot, it's going to be marked by 1. For the cold value, let's say 0. Or here we have different attributes. Then pen either exists or not exist. Pencil exists or not exist. Eraser exists or not exist. Anyway, the tool name or the class name is one-hot encoder. For ranking, you can propose anyway. Okay. So as your friend says, we may mark excellent by 2, good by 1, bad by 0. Then we replace accordingly. Okay. So ordinal, easy. Just you put unique value for each attribute, then you replace accordingly for each record. For nominal, no, you need to ensure that you don't create nature of ranking. So we cannot apply the way of ranking from ordinal into nominal. Okay, I hope this helped you to understand. Same, let's say if you have a data set of pictures of animals, like dog, cat, cow, this is nominal. Unless the tasks say maybe dog is more important than cat, cat is more important than cow, then fine. But if the question or the task doesn't say anything, we cannot simply assume there's a ranking. We can't treat them all equal, right? Same like gender. Gender is nominal, male or female. There is no preferences over male or female. There's no ranking. Ordinal, like this example, excellent, good, bad, or maybe fantastic, okay, don't like. So we can rank. We can see, for example, don't like is the worst. Okay, maybe 50-50, fantastic is great. Okay, there is a nature of ranking in there. This is another example showing you what happened. This is original data for teams and point. Now, team, we have team A, B, C. Is this nominal or ordinal? Nominal. Just team name. We call team A, team B, team C, whoever they are. Okay, since they don't have nature of ranking, then we create for each value 1 column, same like in the earlier example between pencil, pen, pencil, eraser. And then we put 1 represent, like team A, Then we put under team A 1, team B, team C 0. How to apply in Python? You see just 2 lines or 3 lines. You import the class name, one hot encoder, you create an object, then you call fit and transform. You call fit and transform, okay? You can go home and try. By the way, sometimes if you don't understand and you like to emphasize or reinforce your understanding, go prepare this example inside Python. Just prepare it, hard-coded. Then call one hot encoder, fit and transform, print on the screen, see whether the result is same like this or not, right? This is a helpful way because sometimes we need longer time to process. So do it like this. For ordinal encoding, if we say the same example, if the question says A, B, C, it has different ranking of teams. Maybe team A refers to the national team. Team B refers to the district team or local team and so on. Then in this case, we have nature of ranking. But by default, if the question doesn't say anything, we may infer they have no ranking. Okay, unless it's quite clear, like I'm telling you, not satisfied, neutral, satisfied, nature of ranking, right? Sad, neutral, happy, ranking. You can say which one better, which is worse, which is the worst, okay? Or here I put also label encoding. If the target variable, if you have target variable also with labels, let's say like team, you are predicting which team is going to maybe participate in the event, team A, team B, team C. Then also there's a label encoder you can use in Python. The only difference between ordinal encoder in Python, this one, and label encoder, what is the difference? In ordinal encoder, gives you the capability to provide the ranking, the actual ranking. How Python will understand, for example, team A must be the highest, team B, team C. So when you call ordinal encoder here, when you define an object, there's category as attribute, as argument for the class name, and then you say categories, you create a list saying A, comma B, comma C. So Python will understand A is the highest, B the second, C the lowest, for example, or vice versa. Okay, so if you like to predefine to Python, tell the exact sequence or the rank of categories, then you can use ordinal encoder. Label encoder doesn't have this ability. Still can assign 0, 1, 2, 3, 4, 5, but Python will decide which one to get 0, which one to get 1, which one to get 2. If you have predefined order, then you can assign yes. Okay, very good. If now your friend is asking, why cannot use here values as 1, 2, 3? Because if you put here team, saying this, and then you replace A by 2, for example, B by 1, C by 0, then you are giving the inference that these have ranking, because 2 as a number is larger than 1 as a number, and 1 is larger than 0. So we don't need, because if you use numeric value, you need to be careful, because numeric values have ranking. We know 0 is the lowest, 1 comes next, 2, and so on. So we need to avoid this understanding. So we need to break the sequence. We don't need to have ranking sequence. So the simple way, just you create for each value, each unique value, 1 column. Then just you can use 0 or 1. And 0 or 1 here means either exists or doesn't exist. Okay? Like in this case, either these points belong to team A or not, team B or not, team C or not. So when we see there's 1 under team A, we know the 25 points belong to team A. That's it, belong to team 8. We're not talking about any ranking. Okay? Clear? Very good question. Any other one?